Okay, 2.6. Number 3, express the inequality as an interval, okay, and sketch its graph. So, number 3, excuse me, x is less than -2, so on our number line, 0, 1, 2, that's -2, and it's not equal, so it's open. Reshade to the, let me just change the thing there. Boom. There's what it means. Okay, and then we go back and we need an interval. So the interval notation, your smallest number is first, negative infinity. The biggest number is second, always. It's not included, so it's parentheses. All right, and now we want to look at, oh, that's not what I wanted to do. Come on. Okay, number 5. All right, so 5 is x is greater than or equal to 4. So smallest number is 4, the biggest number is positive infinity. It's equal at 4, so it's a closed bracket and an open parentheses. And parentheses 0, 1, 2, 3, 4. It's going to be a closed dot at 4, and it's going to be shaded to the right. And that's what that would look like. All right, let's move on. Number 7, same thing. So now, let's go ahead and do our number line here. And -2, 0, and 4. And it's between those two. It's not equal at 2. It is equal at 4. So put a dot there and then shade everything in between. And that would be -2 is first, then 4. Parentheses, bracket for being shaded in. That's number 7. Number 9, same thing. Between 3, 4, 5, 6, 7. All right. It's equal at both. So we're just going to go ahead and put a dot at both, close dot, and shade in between. And how we say that in interval notation, 3 is the lowest, 7 is the biggest, bracket, and a bracket for being closed dot. All right, number 11 is between 5 and -2, so it's backwards. You still do it correctly. -2, -1, 0, 1, 2, 3, 4, 5. It is an open dot at 5, and it's equal at -2. So we're going to put a dot at -2 and then shade to the 5. All right, so x is less than 5 but greater than or equal to -2. It's just written backwards. So now we need to do interval notation, bracket, parentheses, -2 is first and 5 is second. All right, now we have the interval notation. Let's write the inequality. So -5 is the lowest, 4 is the biggest. Put less than symbols in, put an x there. Now where there is a bracket, we put an equal sign. Boom, that's done. Do the next one. -8, x, -1, less than, less than. They're both brackets, so these are going to be equal signs. And 4 is the smallest and infinity is the largest, so what that means is you're going to put x over here, and you're going to say x is greater than, and since you have a bracket, equals to 4, greater than or equal to 4. And 19, negative infinity is first, so it's going to go all the way to -7. So x is going to be less than -7, not equal to, because that's a parentheses. Solve the inequality, express the solutions in intervals whenever possible. Okay, so 21, 3x minus 2 is greater than 12. Add 2, 3x is greater than 14. Divide off the 3, x is greater than 14 thirds. Okay, so interval notation would be 14 thirds all the way to positive infinity, not included. Okay, 23. -2 minus 3x greater than or equal to 2. Okay, so we add 2 to both sides. And then we divide off a negative. So we're dividing by a negative, so that needs to change to its opposite direction. X is less than or equal to -4 thirds. So negative 4/3 is the biggest number. It's a bracket because it's equal to. And negative infinity is where it's coming from. All right, so I'm going to erase both of those here in a second. And there's the answers. Next is just what we said. Let's go on. Let's erase those and do 25 and 27. All right. Number 25. 2x plus 5 is less than 3x minus 7. So I like my letters on the left side. It makes it easier to do your interval notation. So I'm going to subtract 3x. So negative x plus 5 is less than negative 7. Don't forget the minus sign. Subtract 5. Negative x is less than negative 12. So we're going to divide off a negative 1, which changes that to greater than. So x is greater than 12, so that means 12 is the smallest. There's no equal sign, so it's parentheses. 27, 1/4 x plus 7 less than or equal to 1/3 x minus 2. So I'm going to multiply everything by the common denominator 12 and rewrite the whole thing. So that would be 3x. 12 divided by 4 is 3. 3 times 1 is 3. Plus 84 less than or equal to 1 times 12 is 12, divided by 3 is 4, and 24. So let's subtract 4x to the left to keep our variables on the left side. That's negative x plus 84 is less than or equal to negative 24. Subtract 84. Get negative x less than or equal to negative 108. And again, we can multiply by negative 1 instead of dividing by negative 1. It's still the same thing. Change the direction. Greater than or equal to positive 108. So it's greater than or equal to, so equals bracket to positive infinity. Okay, there's our answers. All right, number 29. Same thing, just keep going. So 29 is negative 3 less than 2x minus 5 less than 7. So there's two sides, two equal sides. So we're going to plus 5 to the right and plus 5 to the left. And we get 2 less than 2x less than 12. And now we divide off the 2. And we get 1 less than x less than 6. All right, so solve it and express in terms of intervals. So 1 and 6, smallest numbers on the left always. No equal sign, so it's parentheses. 31, 3 less than or equal to the complex fraction. So we're going to multiply everything by 5. And the 5s will reduce out. I'm sorry. In the middle, they reduce out. On the left side, we have 15, less than or equal to 2x minus 9, less than 35. Now, just a normal thing, let's add 9. So add 9 to both sides, left and right. And we get 24, less than or equal to 2x, less than 44. And now we divide off the 2. And we get 12 less than or equal to x less than 22. So 12 is the smallest, 22 is the largest, and it's not equal to 22, but it is for 12. And there are those answers. Let's get rid of those and do 33 and 35. 33. 4 is greater than 2 minus 3x over 7, greater than or equal to negative 2. So multiply everything by 7. And the middle 7s reduce out, and we have 28 on the left, 2 minus 3x on the right, or in the middle, and then negative 14 on the right. Now, we multiplied by a negative 2, but we don't change that because we're really multiplying by 7. 7 is positive. It's what you do to the inequality. So we're not changing that direction. All right, so now let's go ahead and subtract 2. And we get 26 greater than negative 3. Don't drop the minus sign. And that's negative 16. Now we divide off a negative 3. Since we're dividing by a negative, this has to change directions. So 26 over negative 3 is equal to x, which is less than or equal to positive 16 thirds. So negative 26 thirds to 16 thirds. It's equal at 16 thirds and not at the negative 26 thirds. Now, 35. 0 is less than or equal to 4 minus 1/3 x less than 2. So I want to multiply everything by 3. You do not have to. Every term. So we get 0 less than or equal to 12 minus x, because 1/3 of 3 is 1, less than 6. Subtract 12 from all sides, and we get negative 12 less than or equal to negative x, don't drop the minus sign, less than negative 6. And now we're going to divide off a negative 1, and we get 12 greater than or equal to x greater than positive 6. So always your smallest numbers first, and then the bigger number. So this is why this is important. 12 is equal to, 6 is not. And those are the answers. Solve the inequality and express the solutions in terms of intervals whenever possible. So smash that like button. Just kidding. Let's see. Let's go ahead and notice that we have to put everything together, distribute, and then we can solve it from there, because we can't do it any other way at this point. There are some other ways, but we haven't gone through them yet. So let's go ahead and distribute everything. So distribute, and on the left we get 8x squared minus 12x plus 10x minus 15. And on the right side, you're going to get 8x squared minus 56x plus x minus 7. So combine like terms, and it's 8x squared minus 2x minus 15 less than or equal to 8x squared minus 55x minus 7. So if we were to actually subtract the 8x squareds, they would cancel out. Literally just canceled. And we have minus 2x minus 15. Don't forget the minus sign. Less than or equal to negative 55x minus 7. So now we're going to add 55 to the left because we like our variables on the left. That's 53x minus 15 less than or equal to negative 7. Don't drop that minus sign. And now we're going to add 15 to both sides. And we get 53x less than or equal to 8. And divide off 53. And we get x is less than or equal to 8 53rds. Less than, so 8 53rds is the biggest. It's equal, and the smallest would be negative infinity. Moving on to 39. All right, so let's square both sides here, people. So this is x minus 4 times x minus 4. So if you have to distribute, distribute. So x squared minus 8x plus 16 is what that's going to be. On the right, we have x squared plus 12x. Now when we subtract x squareds, those will literally cancel out. So negative 8x plus 16 greater than 12x. So again, I'm going to subtract 12x to the left, and we will get negative 20x plus 16 greater than 0. And then I will subtract 16 to the right. Negative 20x greater than negative 16, and divide by a negative 20, which changes the direction, and that's x is less than, this becomes positive. 16/20 reduces by 4 to 4/5. So x is less than 4/5. So 4/5 is the bigger number. Negative infinity is the smallest. And there's no equal sign. 41. Okay, so 3x plus 2, if it's 0, there's no solution, okay? Because that means the denominator is 0. If 3x plus 2 is negative, then you have 4 over a negative, positive or negative, which is a negative, which that means that's not going to work either because it's wanting to know values of x that make the whole thing greater than 0 or equal to 0, okay? Now, the only way the whole thing can be equal to 0 is if the 3x plus 2, I don't know, you can't make that fraction 0, okay? So what we're going to do is say 3x plus 2 has to be greater than 0. And if we solve that, then we have our answer. So 3x plus 2 is greater than 0. 3x is greater than negative 2. And divide off the 3. X has to be greater than negative 2/3. And there's your answer. Now there's no equal sign, so it's in parentheses. Okay, same thing here. You try and then press play and see what we do. Try to figure out your positives and negatives here, because this means greater than 0 means the whole thing has to be positive. That's what that greater than symbol means. You have a negative on top. Think about what the bottom has to be to maintain the whole thing being positive. Okay, so that means 4 minus 3x has to be negative. Can't be equal to 0, has to be negative. If it's equal to 0, then, there's no solution. So, solve it. So we subtract 4, don't drop the negative, divide off the negative, changes the direction. X is greater than positive, plus 4/3. So greater than means 4/3 is smallest. It's not equal to, so that should be your answer. All right, 45. So you're going to have to square that. So 1 minus x times 1 minus x. And you get 1 minus 2x plus x squared. And again, this means it has to be positive. The top is positive. So that means the bottom has to be positive. If it's negative, then you have a negative action. You have a positive or a negative, and you can't do that. So the bottom has to be positive. So we solve it the way we've been solving everything else. So I'm going to rearrange it here. Plus 1 greater than 0. Okay, so again, you factor it back into that. That's what it'll factor into, x minus 1 squared. So you might be sitting there thinking, wait a minute, x minus 1 is not the same thing as 1 minus x. That's true. So 1 minus 3 is not the same thing as 3 minus 1. But if we are squaring it, 1 minus 3 is negative 2, and 3 minus 1 is 2. If you square both of those, yeah, that's a positive 4 and a positive 4. Okay, so you have these two things. X minus, we'll just use what's up top so you're not confused. 1 minus x and 1 minus x. All right, they can't be equal to 0, all right? And we need it to be positive. All right, so, whoops, both of those have to be positive. Or they both have to be negative, because a negative times a negative is positive. So what we're going to do is set each one, 1 minus x, is greater than 0 for it to be positive, and 1 minus x is less than 0 to be negative. Okay, so if we're solving it here, 1 minus x greater than 0, subtract 1, you get negative x greater than negative 1, divide off the negative 1, change directions. X has to be less than 1. It can't be 1. All right? So if you had 1 minus 1 up here, that's 0. But it has to be less than 1. So 0, negative 1, negative 2. And that'll make all of those positive. Now, negative, if they're both negative, which when we square it, that means it's going to work. So we need to solve for the negatives. And it's the exact same thing again. Subtract 1 negative x is less than negative 1, and divide off the negative 1, change the directions, x is greater than 1. So x has to be less than 1 or greater than 1 for this to work. And if we're doing interval notation, it's negative infinity to 1, not including 1, unioned with 1 to positive infinity. All real numbers except 1. All right, here we go. Let's solve these inequalities. Two different inequalities, or not absolute values, sorry. X is less than 8, the original, and then x is greater than negative 8. So you have to change the inequality and the sign. So those are your answers at this point. X is less than 8 or greater than negative 8. So negative 8 is the smallest number. 8 is the biggest number. They're not equal at either side, so that should be your interval. Okay, 49. Do it yourself. So it appears that x is between negative 5 and 5, but look closely. X has to be bigger than 5 and less than negative 5. So on a number line, this is what you're looking at, negative 5 to positive 5 here. X is greater than 5 and equal to. So you're looking at that and less than or equal to negative 5. So x isn't between them. All right, so what you're going to do is negative infinity to negative 5, including negative 5 because of the equal sign, union with 5, including 5, all the way to positive infinity. 51. Just because it has a decimal doesn't mean anything. Do it the exact same way. X plus 3 less than 0.01. X plus 3 greater than negative 0.01. Just because it has a decimal doesn't change anything. Solve it the same way. Subtract 3. So x is less than, well, what is 0.01 minus negative 2.99? And we subtract 3 over here. X is greater than negative 3.01. So x is less than, think of it on a number line if you don't know what you're doing. So we have negative 2.99, negative 3, and negative 3.01. All right, so x is less than negative 2.99, going this way. X is greater than, going this way, negative 3.01. So x is between it. Your interval notation, you have to put your smaller number first. So negative 3.01 to negative 2.99. And parentheses because they're not included. 53. Okay, again, you have to get this by itself. So x plus 2 is greater than or equal to 0.2 minus 0.1 is 0.1. So x plus 2 is greater than or equal to 0.1. X plus 2 is less than or equal to negative 0.1. Subtract 2, subtract 2. X is greater than or equal to negative 1.9. And x is less than or equal to negative 2.1. So again, where are these on the number line? Negative 1.9, but negative 2.1 is smaller, further left on the number line. X is greater than or equal to, so greater than or equal to, colored in dot. Greater means to the right, less than, it's equal to, shaded to the left. So it's not in between, all right? So we're going to say negative infinity to negative 2.1, including 2.1, union with negative 1.9, including negative 1.9, to positive infinity. Number 55. Two x plus 5 is less than 4. 2x plus 5 is greater than negative 4. Subtract 5. Subtract 5. 2x is less than negative 1. 2x is greater than negative 9. Divide off the 2. And x is less than negative 1/2 or greater than negative 9/2. All right, so again, negative 1/2. Negative 9/2 is bigger, or excuse me, further left on the number line. So x is less than negative 1/2, open dot, shade to the left, less than. Greater than negative 9/2, so open dot, greater than means to the right. So x is between it, so negative 9/2 is the smallest number, negative 1/2 is the biggest number. It's not equal in either one, so it's parentheses. 57. All right, let's get the parentheses, or the absolute value by itself. So we're going to subtract 2, so negative 1/3, 6 minus 5x, 5, greater than or equal to negative 1, multiplied by negative 3. And when you multiply by a negative, that changes to less than or greater, or less than or equal to. So 6 minus 5x, absolute value, less than or equal to positive 3. Then you split them apart. 6 minus, without the absolute value. 6 minus 5x less than 3. 6 minus 5x greater than or equal to negative 3. Subtract 6. Do not drop that minus sign. Negative 5x less than or equal to negative 3. Divide off a negative. So change it to greater than or equal to. And that's positive 3/5. Subtract 6. That's negative 5x greater than or equal to negative 9. Divide off a negative. So that makes this less than or equal to. So x is less than or equal to positive 9/5. Okay, x is greater than 3/5 and less than 9/5. So 3/5 is smallest. It includes 3/5. It's smaller than 9/5, but includes 9/5. That should be our answer. And there you go. Number 59. Okay, split them apart. 7x plus 2 is greater than negative 2. And 7x plus 2 is less than positive 2. All right, so I think we already discussed this once, but I'll go ahead and finish the problem. 7x is greater than negative 4. Divide off the 7. And x is greater than negative 4/7. Subtract 2 over here, and 7x is less than 0. Divide off the 7, and x is less than 0. Okay, so supposedly, x is between negative 4/7 and 0. Not equal to those things. All right, well, let's just plug that back in and see what you get. Watch this. 7 times negative 4/7. That's what we're plugging back in. All right? It's not equal to negative 4/7, so let's make it negative 3/7. All right? Because it's between negative 4/7 and 0. And we're going to add 2, and that's supposed to be greater than negative 2. So here, the 7's reduce out, and we get the absolute value of negative 3 plus 2 is greater than negative 2. So that's negative 1. The absolute value of negative 1 is greater than negative 2. The absolute value of negative 1 is 1, and 1 is greater than negative 2. All right, let's look and see what the book says. So as we can see, the answer is supposed to be negative infinity to positive infinity. Okay, well, think about this for a second. We did the operation, the procedure, correctly. Let's plug in negative, or let's go bigger than 0. How about we plug in 7, positive 7? All right, so let's just do this over here, and we get 7 times 7 plus 2 is greater than negative 2. Well, think about this for a second here. 7 times 7 is 49, plus 2 is 51. Greater than negative 2. Well, of course 51 is greater than negative 2. But 7 doesn't fit in with what we have. Okay, so now you have to use your brain here. Absolute value is going to be positive. It wants to know the absolute value, all the numbers that you can plug in for the absolute value that is greater than a negative value. Well, everything you plug in there, no matter what it is, when you take the absolute value when you're done, is going to be positive. So everything is going to be the answer there. All right, look at this one. The absolute value has to be greater than 0. Again, let's take a look at solving this. 3x minus 9 is greater than 0, and 3x minus 9 is less than 0. Add 9. 3x is greater than 9. Divide off the 3. X is greater than 3. Add 9. x is less than 9. Divide by 3, x is less than 3. Well, greater than 3 and less than 3. But it can't be 3. Plug 3 in and see what you get. 3 times 3 minus 9. Is that greater than 0? So 9 minus 9 is 0. The absolute value of 0 is 0. Is 0 greater than 0? No, it's not. Let's take a look at the answer in the book. And what we see here is that it's exactly what we thought. Whoops, let me grab this here. It can be all the numbers except for 3. It can be greater than 3, and it can be less than 3, but it can't be 3. So we get this very thing, the union from negative infinity to 3, and from 3 to positive infinity. But 3, if you plug 3 in, it's going to make it equal to 0, and we don't have the equal sign there. So this one works just fine. 63. Now, this says the absolute value is less than negative 1. So let's cut to the chase here. Let's look at what the book says is the answer. It says no solution. Why? Well, because absolute value has to be positive. And this is telling us it has to be less than negative 1. It can't be less than negative 1. Can't be a negative. So there's no solution to this. So what I'm going to do here is I'm going to go ahead and solve this just so you can see what happens if you were to solve it. 2x minus 5, because this is technically, you see these and you say, oh, first step, I'm supposed to do this, I'm supposed to change that sign and change that sign, and now add 5, so I get 4 there, and I get 6 there, divided by 2, x is less than 2, and x is greater than 3. So on a number line, x is less than 2 and greater than 3. Not equal to, so less than. So we're looking at less than 2 and greater than 3 with open dots at 2 and 3. Okay, well, let's plug one of these numbers in. Okay, there's no double shading here is my point. For this to work, all these numbers, any of these numbers can be here. So let's pick 0. All right, so if we plug 0 in, to this, 2 times 0 minus 5, is that less than negative 1? Well, look what happens. 2 times 0 is 0, 0 minus 5 is negative 5. The absolute value of negative 5 is 5. That's not less than negative 1. No matter what we put in here, it's not going to give us a negative. So it's no solution. It's okay that you solve this, but at some point you have to take a look and understand that absolute value cannot give you a negative value. Okay? Your answer can be in the negatives, like the last problem. You can go from negative infinity to 3, and then from 3 to positive infinity. So your x value can be negative, but the overall problem in this problem here, number 63, is when it's all said and done, there aren't any values you can put in there where the absolute value is going to make it negative. All right, now look at this. Greater than or equal to negative 3. This is possible here. So let's break this down and see what happens. All right, split them apart. So 2x minus 11 is greater than or equal to negative 3, and 2x minus 11 is less than or equal to 3. Add 11. 2x is greater than or equal to 8. Divide off the 2. X is greater than or equal to 4. Sorry about the tapping. I left my AirPods in another spot. So plus 11, we're almost done. And we get 2x is less than or equal to 14. And divide off the 2, and we get x is less than or equal to 7. All right, so greater than or equal to 4, less than or equal to 7. Okay, 4 and 7. So they're both equal to, so it's a colored in dot. Greater than 4 and less than 7. So let's pick one of those. Let's pick a number outside of this. Well, let's look, see what the book says. Let's go ahead and do the interval notation. So brackets, because it's equal to. Both of them. Now, what's the book say? Okay, now take a look at that. All numbers that we plug in for x are going to work, not just what we solved for. Think about what this is saying. Just think about this for a second. The absolute value is always going to give us a positive value. Well, aren't all positives greater than or equal to negative 3? No matter what I plug in for x, it's going to be true. All right. 67. Now, you need to solve this because this says greater than or equal to 2. So it's possible you could plug something in here that gives you a 0 or a 1 between 0 and 2, and that would make this false. All right, can't be negative, but you have room for error there. So now we need to solve this. So we're going to break this apart. Okay, so we split it apart. That should be negative there. Okay, so multiply by 5 on both sides. Okay, both sides. Oops, 5, not 2. And we get 2 minus 3x is greater than or equal to 10, and 2 minus 3x is less than or equal to negative 10. Okay, and now solve it like normal. Let's subtract 2, and don't forget the negative. That's negative 3x greater than or equal to 8, and negative 3x less than or equal to negative 12. Now we're going to divide by a negative 3, and since you divide by a negative 3, that switches the sign, so we get x is less than or equal to negative 8 thirds, and x is, again, you divide by a negative, so switch the sign, greater than or equal to positive 4. So negative 8 thirds is supposed to be less than or equal to negative 8 thirds, and so that means that way, and greater than or equal to 4, so greater than 4 is that way. So how do we say that in interval notation? Negative infinity to negative 8 thirds, including 8 thirds. Let's write this up here. Negative infinity to negative 8 thirds, including 8 thirds, never infinity, union with, including 4 to positive infinity. Let's see what the book says. And there you go. Pretty cool. All right, so hopefully you're getting an idea of what is possible and what isn't. Let's go on. We're almost done. Okay, now think about this. The top is positive, all right? The top is positive. The bottom is going to be positive. Is it possible that it can be less than 2? And your answer should be yes. It could be anywhere from 0 to 2, but not including 2. So there is room for a solution here. So we need to solve this the way we've been doing it. So let's see here. We need to get the absolute value by itself. So before I split it apart, let's go ahead and remove it from the denominator. Okay, and let's do this. Multiply both sides by the denominator. And then we're going to divide off the 2. But I'll go ahead and do it separately here. So we now have 3 times the absolute value of 5 minus 2x on the left, still less than. 2 times the absolute value of 5 minus 2x. And I'm going to divide off the 2 on both sides. I'm sorry. The 5 minus 2x absolute value reduces out on the left side. So on the left side we have 3 halves, less than, and the 2's reduce out. The absolute value of 5 minus 2x. All right, so I'm going to flip this around, and when I do that, I need to flip the sign as well. I just like having my absolute values on the left. That's just a preference. So that means, notice the open end here is facing the absolute value, and now I have the open end facing the absolute value here because I switched everything around. And that's called the symmetric geometry term there, okay? Symmetric property. Okay, so now we can solve it. Let's see what we get. 5 minus 2x is greater than 3 halves, and 5 minus 2x is less than negative 3 halves. So let's move everything up and keep going here. So subtract 5, subtract 5, subtract 5, subtract 5. Do not forget the negative there. It's still attached. Negative 2x is greater than 3 halves minus 5 over 1. I'm just setting up so you can get a common denominator. So a negative 2x is less than negative 3 halves minus 5 over 1. All right, so we need a common denominator. So we are going to multiply by 2 to get a common denominator. And still it's negative 2x greater than 3 minus 10 all over 2. Negative 2x less than a negative 3 minus 10 over 2. Negative 2x is greater than negative 7 halves. Negative 2x is less than negative 13 halves. Divide by a negative 2. And when you divide by a negative, you have to switch your direction here. So x is less than. We have a negative over negative, so it's going to be positive. You have a fraction inside of a fraction, so it should be the top, 7 halves, times the reciprocal of the bottom, 1 half. So x is less than 7 fourths. Next side, x is greater than, because we divided by a negative, you have to switch the sign. Fraction inside of a fraction, we have negative over negative, it's positive. So you have 13 over 2, the top, times the reciprocal of the bottom. And so x is greater than 13 fourths. So less than 7 fourths and greater than 13 fourths. So according to this, it's negative infinity to 7 fourths, not including it, union with, not including 13 fourths, to positive infinity. All right, let's take a look at the book. And you see we did it right. All right, next problem. 71. Now. Okay, so remember, this is like doing two different problems. So like negative 2 less than absolute value of x, and absolute value of x less than 4. So we break each of these into two other problems. Negative 2 less than x, and positive 2 greater than x. Here we have x less than 4 and x greater than negative 4. So those are your answers. So where is x here, the absolute value of x? X is greater than negative 2 and x is less than negative 2. All right, negative 2 to 2, greater than negative 2, which means it's going to the right. And it's parentheses for that one. This is less than 4 and greater than negative 4. So negative 4 is smaller than 4. And again, those are your possibilities. Okay, so why does negative 2 and 2 not work then? So if we plug negative 2 back in, let's go ahead and plug negative 2 in. The absolute value of negative 2 is positive 2. So positive 2 is greater than negative 2. It is less than 4. All right, what about 2? If you plug 2 in, you're going to get the same thing. So again, it comes down to understanding that negative 2 is always going to be less than the absolute value. We don't even need to consider those. That's why it's not in the solution set. Because from 0 to 2, if we look at the answer of negative 2 to 2, from 0 to 2, that's covered in that response from negative 4 to 4. So that's why they don't have negative 2 and 2 in the solution key. All right, last problem. Let's do it again. Split them apart into two problems and then split them again. All right, so now let's split them up into two problems. One less than x minus 2 and negative 1 greater than x minus 2. So let's change the signs, change the inequality. So here we have x minus 2 less than 4 and x minus 2 greater than negative 4. So solve by adding 2, and we get 3 less than x, which really is x greater than 3. And we add 2 here, and we get 1 greater than x, which is really x is less than 1. So it's less than 1 and greater than 3. So on a number line, 1 and 3, less than 1 goes that way, and greater than 3 goes this way. And this one, add 2, and we get x is less than 6, and x is greater than negative 2. All right, less than 6 and greater than negative 2. Negative 2 and 6. Less than 6, greater than negative 2. So that right there is that solution. Okay, so let's see what the book says. Okay, so notice it says negative 2 to 1. So what we're looking at here is, I gotta move the whole thing. Let's just redraw it here. Okay. Put this one over here from 1, 2, 3. Oh, this is going to be 1 here and 3 there. Goes this direction, and 3 goes that direction. Okay, so where are they overlapping? Because like the last problem, one takes care of the other, and they both have to show everything. So from 1 to 3, there is not double shading. So it's really from -2 to 1, union with 3 to 6. That's where the double shading is at when you have a complex absolute value problem. All right, good luck.